Now let's look at some examples. Here are our friend the camera. We already seen that extensively before, so you can open those with the plugin and see again how they're made. They're all using the anim layers provided with the plugin. Next we have those houses. And this example is actually interesting because the mesh and the data texture come from Unreal Engine content examples project from the Pivot Painter section, and we can actually import them using the plugin. Here we move it to the Unreal Content Example project, and this is the level for the Vertex Animations, Pivot Painter 2. That's our house. We can totally open it with the plugin. Well, it will say that we don't have material layer support, and it will also recognize the UV channel as a Pivot Painter UV channel. Now you can see already it shows us all those parts and pivots, and then that's the data textures that comes with Unreal content examples. So we can just put them here, and if you look closely, those pivots will be adjusted. And now it's exactly like those we have in our demo project. And this actually shows something maybe important for this version. We actually don't have any intermediate like format to save this data. The plugin always reads the data from the texture directly, from the material instance. So when you open a mesh, it recognizes the anim layer, and it knows how the texture parameter is called, how the other parameters are called. It will load those textures, and it will read the data from the texture exactly like the material does. Probably in the future we will need to add some intermediate additional asset to store data, because probably in some cases you cannot just get away with just those textures. You need to store something more. We are back in our demo level, and let's check it out here. We will open it with the plugin. As you can see, there's many parts, 60 parts. We'll show the order. And so various things. First, well, when you open it first, probably the order will be not assigned like this. Probably it will be assigned at random. So you need some way to order them from bottom to top, so they appear like this from bottom to top. And for this, there is an operation. If we select everything, we go into operations, and there is a thing called geo order. The geo order will order parts by like direction from top to bottom or from bottom to top, etc. So here we can choose order by bounce z min. Probably we will choose them by pivot z min, just to give an example. And then I just run it. Well, change it a little bit, but still it looks okay. Now another thing, if you open it the first time, the pivot will be all looking in the same direction. So here we can simulate it by doing reset. Now our pivots are looking like this, and if you run this, it will look funny. Well, maybe that's what you want. But if you don't want this, we can here just rotate multiple things at once, and I will just like select everything like this. I selected all those pieces that I want to rotate, and I will just all rotate them together. So when you rotate multiple selected objects, it rotates them all together. So when I play now, it's good again. And sometimes it's difficult to select like this, you know, without overlapping something, because by default the selection select also invisible parts. So here in the bottom you have selection parameters, and here you can say marquee ignores occlusion. So in this case it will not ignore occlusion and will select something like this. Or like this. We didn't select the back wall. So that's it for this house. The neighbor is basically the same thing, but the anim layer is configured differently. If I open the anim layer here, we have this checkbox fixed location offset unchecked. So it means if it's checked, all the parts will arrive from the offset specified here. This is just above 2.5 meters. And if I uncheck it, all the parts will arrive from there, like forward vector direction. So in this case, from here. And if I play it, you see, really, the roof really arrives from the front. And if I check it and apply, you will see the roof and everything above just from above. So that's it for the difference. Now let's study this car example. This is a pretty complex model with 5 materials and 2 V-channels. And so first we transformed that to a static mesh because there was some problems with the modeling mode and the skeletal meshes. And then if we open it with the plugin, you see that there's a lot of parts, 200 parts. And otherwise, basically it's the same assembly material as the houses. Just the number of parts is bigger and the model has more variety. So we here really needed to use the hide feature, pressing H. By the way, the shortcuts are listed here in help to see the insides of those pieces. And like here you have those lights and there are pieces inside. So that's pretty complex. We have also pieces coming from above and pieces coming from the side. And also some pieces comes from like this, from this direction. For the order, let me unhide everything. To start, you can select everything and in geo order select bound Z max, which means the top of the bounding box of each piece. So the highest thing here is the body of the car, and this will arrive the last. So if I select everything and I reset everything, so if I don't click reset, it will just shuffle the existing order numbers to rearrange them, and if I reset it will just restart the numbers from 0. So here again I select everything and I run it, and as you can see it's already looking pretty decent. So then you maybe fix some of those orders manually. Here if we look at the material, so here you see that they arrive from 2.5 meters. That's the distance from which parts arrive. If I put like 1 meter and apply, you see if I put these centimeters, you can see the difference. That's pretty cool actually. Yeah, with those effects you can really, you never know what you can obtain without trying. If I put 0, it just appears like this, but still something cool. And then Well, maximum number of rotation is 0 because doesn't really make sense for those pieces to rotate. And here actually you can disable the rotate altogether, and it's disabled because we don't need to rotate them, and it's a static switch that removes all the rotate code. So instead, just multiplying that by 0 will really simplify the shader. And then you have time to build, so pretty obvious. That's the number of sub-objects. You don't have to change. It's controlled by the plugin. We also can use elastic. It'll look a little bit different. You see the pieces overshoot now. And then we actually enable here the scale. So the object will appear scaled to 0 and then expand. And here you have the scale power, so that they will expand very, very, very quickly. And we put the scale because we actually really need it. If I remove the scale, you will see something happens. So those lights here, the glass is made as translucent material. And our trick with the masked materials, you cannot use that obviously on the translucent material. So we just scale them in the beginning. And then you see they are not here anymore. So that's how this car works. Pretty simple after all. Now let's check this cube here. It's another material layer called polyfold. And basically it's very similar to the assembly, but instead of translating the pieces, it will rotate them around the x-axis in order specified. So to create the effect, we will first specify the orders, like you've seen with it before. Like, for example, we can select everything in order we want and then use operation order to enumerate them. And then we need to place those pivots on the edge between neighbor pieces. And for this, there is also an operation. We select everything, and operation is called polyfold. This operation will move the pivot on the edge of the neighbors and rotate it along the edge. So if I run it, you see it worked, but some of the pivots will be aligned in the different direction than the others. So for example, here arrives from the top and here's arrive from the bottom, and I want them all arrive from the top. So for this I will just go here and fix that by hand. And now everybody is correct. And then if I don't want to rely on the order attribute, because maybe I don't have it, I can also use it without. And in this case, I can check this checkbox. It will be using the order of the selection, like this. Now let's look at this slightly more complex example of hierarchical vertex animation. So those rings here, they are parented to each other. The first ring is the root, and the second ring is the parented to the first ring and rotating in perpendicular axis, etc. We can see that better here. So that's our model. We have our 4 rings. The parent is stored in the position texture alpha. And if we click here, this is the root. We can actually show here the ID. So this is the root ring, and this is the first ring, which is parented to the root, ring 0. And you see this dashed line here that shows the parenting. And then this ring is parented to the 1, and the ring 3 is parented to the 2. And you see that all those axes, which counts here is the forward vector, is the red axis. So each axes are perpendicular each time. And so when we rotate them, that creates this movement. If we look the material, this is the anim layer that comes from with the plugin rotate H. So if we look the anim layer, we can change the speed of each depth independently. Now they're all set by default to 0.25, so we can actually like cancel the movement of everything but the root layer, root level. Then if we see, they will just all follow. And then I can put some speed here. That's the smallest string. And then I have to apply, of course. Then you can see. You can also put a negative speed. You'll rotate in another direction. Apply. So now let's see how to set up those parent-child relationship. The easiest way is to here just put the number like we had parent. So the 0 will be parented to 3. And by default, the root should be parented to itself. It will actually work if you parent it to 3, which is kind of funny, but it will rotate like this. Then another way is to choose select some number of rings, and then in the operations we have parent, and we have there's two ways. Explain it in the help. First, we can just run it. It will parent everybody to the first selected group, in this case 0, and then you can see that everybody is parented directly to 0. Let's give something like that. And then also I can choose again like this, everybody in order. Click this chain checkbox, which will parent them in chain to each other. So now, as you can see, 1 is parented to 0, 2 to 1, and 3 to 2. And 0 is parented to itself. But that's how you specify the parenting. Now, for the material, there is also a couple of interesting parameters. Basically, you can choose if the base material has a normal map, like here, there are those dots. Then you can check this checkbox, this static switch, and it will calculate the rotation of the normal map correctly, which costs a little bit more. If you don't have a normal map, you can uncheck it, which costs a little bit less, and it will be just flat like this. And then there is another checkbox here. You can specify the speed as alpha instead of those numbers here. You can pass the speed in axis alpha, axis texture alpha. We will see that example later. Now I would like to just briefly explain how this material works. I made a little drawing here. That's our vertex, and that's its pivot. So the vertex will be rotated around this pivot. That is the normal rotation we already seen before. And in this case, we also have a parent pivot, this one. This vertex and the first pivot will be also rotating around this one. So that's the new thing, the hierarchical part. And how we will calculate this? So first we will just rotate it like normally we will rotate this vertex around first pivot, and we will obtain this new position of the vertex. So normally we would here take the difference of two position and output that as vert position of set, and that will be all. But in this case we have another step. We will now take this new position as the position of the vertex initial, and then repeat the same thing with the another pivot, with the parent. And we will rotate it again, and we obtain a new position for the vertex. And that, in this case, we have two steps, and that we will output. So the output will be the difference between the initial position of the vertex and this second step. That will be the vert position of set. Now we will see how it's implemented in the material. So here our material, rotate H, and you can already see those 4 steps from the innermost child to the root. And this function is just implements one step of the rotation and receives the previous position and the texture, the V's, etc., and the speeds here, the 4 speeds, and at the end it produces the result that we output. And here we treat the normal in case we have normal maps or not. But so now the question that we can ask, there are different questions we can ask. First, we think that we store the parent ID in the alpha. So the parent ID is exactly this number, 0, 1, 2, 3. And we need to access the position, the rotation in this case, of the parent pivot. So we need to transform this number into UV coordinates of the parent. And then for this, Unreal already have a couple of functions. There is a function pivot painter to return parent texture info, which will take the index of the pivot and the size of the texture and do the simple math, find the UV coordinates. And then we have also the inverse function that will take the UV coordinates and calculate the index. It's called pivot painter to calculate mesh element index. And all of this is of course possible because our ID and our UV coordinate are uniquely mapped. So 0 is always the top left corner, the first UV, etc. Then another problem we can see here is that, well, there's 2. First, we don't always have 4 levels. For the root ring, we only have this ring, and the vertex of the root ring don't need any special hierarchical part. And in the material, we cannot really like put an if and say that is not executed. So for this, we have those masks here, and basically those masks will just cancel the result of this step multiplied by the value of the mask. So mask is either 0 and 1. And for the topmost ring, for the root level ring, those values here, here, and here will be 0. And this one is always 1 because we always have at least 1 ring. Then the another problem is that, as you can imagine, if we are like here, vertex here, we will first receive the pivot information for this level, so for the third level, and for this one for the second level, this one for the first level. So the order here, it's kind of difficult to understand how to deal with it, because here the order, because of this, basically because of those parameters, order is like fixed. Here we should always start with the 4th speed. And to implement this, we actually will, and the code is here, we will actually first count the number of parents we have. So this way we need our depth, and then we will adjust those UV parameters and the masks, so we always have the correct parameter here matched to this function. So like in the case of the innermost ring, we will here input its UVs, and there the UVs of the parent and of the grandparent and of the root and the speeds. And in the case of, like, for example, this ring, we will just like skip those two, and then here we will insert the UV of this ring, and then of the root ring. So that's the way this is working. And this way to implement the hierarchical vertex animation, it's actually the technique called pivot painter 2, and you can find it in many places. Like you can find the example of this in the Unreal content examples. You can find that in the Unreal implementation of trees, and you can also find that in our own EG2's PP plugin that allows to use speed tree trees in Unreal. The planetary gear is also an example of hierarchical rotation, slightly different. And so you have those gears, and as you can see, small gears are attached to a frame that you can see here, and the speeds are chosen the way they stay connected, like you can see here. So it's like the gears in the car work. The implementation of that is basically the same thing as before. Here only the inner material support the layers. The yellow material is not animated, but that's okay. The only difference that the speed, and instead of giving it as a material parameter, we give it as extent. So in the axis texture, the alpha, we store this extent value, and those values are chosen the way the gear will rotate coherently between them. And then if you go to the Wikipedia and you see, if you checked planetary gears, you have all those configurations listed. So we just took those numbers and put it in here. And it's implemented, of course, as hierarchical rotation. Especially you can see those small rings, call it planets. They are attached to the frame. So that's implemented as real hierarchical movement. Finally, we have those two examples called shutters and fan. In this case, we make a special material layer for just this example, and it's very simple. So as you can see here, we use both alphas, and we put order and extent. So if we show the order here, I can see 0, 1, 2, 3, etc., 2, 3, 4, etc., and the extents are like so. On the left, they are a little bit bigger. On the right, they're a little bit smaller. You can see them here, dotted lines. And as you can imagine, the extent will encode the amplitude of the movement. So for example, this is the biggest amplitude, and it's between 0 and 255, which will be mapped to an angle after that. And the order encodes the phase shift. So this way we have things that are shifted. They're not all going up at the same time. If you look at those, for example, you can see there's slight difference. And you can also see the amplitude here. This one has biggest amplitude. And if I like take this and reduce it, you will see it's not moving that much anymore. And finally, this is like an advanced example. You cannot really edit it with the plugin because here we have 3 different layers. If we check the material level here, we have actually in material instance, we have 3 material layers plus the background. Background is our pass-through that does nothing. And then we have our 3 different animation layers. So one is the shutters that we seen before, one is the rotate, and another that just does the simple movement. And they are applied using the layer blend by color. So if we just take a simple material that shows the vertex colors and put it here, we will see that the shutters is the red, those side pieces are blue, and the fan inside is the green, and which corresponds to our layers here. Also, this is a custom anim config, so the anim layers for the shutters and the data set for editing it, it's located directly here in this folder. And to create that, we need, of course, first create them one by one, and then we combine. Probably in the future versions we will add something for this kind of configuration, so you can edit it with the plugin. But for now, we require that the anim layer go into the background layer, and only one anim is supported for the moment.